Welcome to this video demonstration of Big Cloud Fabric's integration with VMware vCenter. In this demo, you will see how you can streamline application deployment workflows by automating the physical network configuration. We'll also show you how this integration simplifies and enhances troubleshooting across physical and virtual network environments. We're going to demonstrate several ways in which the data center admin benefits from integrating the Big Cloud Fabric with vCenter. First, we'll show you how BCF automates the configuration of port channel or lag connected to ESXi hosts. Next, we'll demonstrate the creation and deletion of logical segments, that is VLANs, in BCF when the vCenter admin creates or deletes vCenter port groups. The third demonstration shows how BCF auto-learns a virtual machine, its vCenter port group, and its physical location, and how the BCF controller programs the fabric accordingly. Fourth is a migration of the network configuration for vMotion. And finally, we'll demonstrate the visibility BCF gives you across the physical and virtual network environment. Here's the topology we'll be using. For the purposes of this demo, we've set up two racks with redundant leaf and spine switches which are managed by the BCF controller as a single fabric. On the vCenter side are two ESXi compute hosts, one in each rack. Each of these compute hosts will have two physical links connected to the BCF fabric. There are multiple VMs in each host, app1 and db1 on ESXi1, and app2 and db2 on ESXi2. web1 is a VM we'll be creating during the demo. Let's look at the BCF controller and the vSphere configuration. Here's the BCF controller GUI. You can see that there's no configuration here. 0 tenants, 0 logical segments, and 0 endpoints. Moving to the fabric view, you can see the two rack topology with two leaf switches in each rack and two spine switches. You can also see the controller cluster consisting of an active and a standby controller. In the vSphere web client, we select hosts and clients, and you can see two hosts, 10.2.18.2 in Rack 1 and 10.2.18.3 in Rack 2. With the Big Cloud Fabric and vCenter set up, we'll see what the data center admin needs to do to administer this integrated environment. First, we'll look at the auto host detection and lag formation. The first thing that happens is that the BCF controller registers with vCenter by adding its IP and login credentials. Second, we enable Cisco Discovery Protocol on the vCenter virtual switches so that the vSwitches send CDP messages on the server physical NICs. Once this is configured, BCF auto-detects the host and automatically forms the lag with the host. There's no manual configuration at all. Let's give it a try. We go to the vCenter vSwitch configuration to verify that CDP is enabled. Under Advanced Settings, you can see that indeed CDP is enabled. Going back to the vCenter topology settings, you can see that this virtual distributed switch, or VDS, has 4 uplinks, 2 for VMNIC2 and 2 for VMNIC3. So the ESXi hosts at 10.2.18.2 and 10.2.18.3 each have redundant links to the physical fabric. At the BCF GUI, we'll register BCF to vCenter. We select Integration and VMware vCenter. Now we can add the vCenter information. We add the name, IP address 10.2.18.4, the username, and a password. Then we add the tenant name. The VLAN is untagged, and we save the configuration. When you configure BCF, It connects to vCenter and gets its updates from vCenter. Now let's go to port groups. You can see that we already have 2 port groups created to the 2 compute hosts. On top is ESXi 2 with VMNIC2 and VMNIC3 connected to Rack 2 Leaf 1 and Rack 2 Leaf 2 on Ethernet 47. On the bottom is ESXi 1 connected to Rack 1 Leaf 1 and Rack 1 Leaf 2 on port Ethernet 37. The important thing to notice is that BCF auto-discovered the ESXi compute hosts, their interfaces, and the lag. If you have tens or hundreds of servers, the hosts and their lags are auto-discovered. Our next step in an application deployment workflow is to create the vCenter port group. This enables the corresponding VLAN or L2 segment associated with the port group on the Big Cloud Fabric. vCenter automatically notifies BCF of the port group creation. You'll see that the configuration is performed in vCenter without having to manually configure BCF. Going to the vCenter web client, you can see that we already have 3 port groups configured for the demo: VLANs 42 and 43, and vMotion traffic on VLAN 45. On the BCF GUI, we select tenants, and you can see the tenant configured for vCenter. Expanding on this, you can see that the logical segments have been created for the 3 port groups VLAN 42, 43, and 45. Let's create a new port group in vCenter and see how it updates the Big Cloud Fabric without having to manually configure BCF. Going back to vCenter, we select a new port group, name it VLAN 41, and set the VLAN ID to 41. And you can see that the VLAN 41 port group is enabled. Now we go back to the BCF GUI, refresh the logical segment, and there's our port group 41, updated from vCenter. With the new vCenter port group up, our next step is to create a virtual machine and associate the VM's VNIC with the appropriate port group. Once you add the VM VNIC to the port group, vCenter notifies BCF of the VM's MAC and IP, its VLAN port group, its physical location, and the ESXi host on which it resides. The BCF controller then enables that VLAN segment membership on the designated lag connected to the host and programs the forwarding table with the MAC and IP of the VM. The VM we're going to be creating is Web1 on host A or ESXi 1. First note that in the BCF GUI, as we click on the VLAN 41 segment, there's no port group membership displayed, nor any endpoints. In vCenter, you can see VMs on the other 2 port groups. Let's go to Web1 and edit settings and add it to the new port group we created. Now the VM is on port group 41. Going back to the BCF GUI and doing a refresh, you can see that the BCF is dynamically updated with the new port group on ESXi 1. Selecting endpoints, you now see the virtual machine Web1 and its IP address 10.100.41.11, its MAC, and the lag where it's connected. Now that the application is deployed and VMs are up and running, we'll demonstrate migrating a VM from one physical host to another. We'll initiate the vMotion in vCenter. vCenter will instruct BCF to dynamically migrate the network policy, and update the forwarding table. Note that if the VM is the first VM in that port group on the new host, BCF will automatically provision the VLAN on the new host's lag port. Similarly, if the VM was the last one in the port group on the old host, BCF will prune the port group from that host. Let's move a VM and observe the dynamic provisioning and pruning. We're going to move Virtual Machine Web 1 created in the last step from ESXi 1 to ESXi 2. First, let's look again at the BCF GUI and the VM we created in the last step. Here's Web 1 on the ESXi 1 lag. Note that the port group VLAN 41 is only on ESXi 1 and not on ESXi 2. Now let's initiate the vMotion. We move Web 1 to ESXi 2. The compatibility check is done and shown successful. Now vCenter is ready to do the vMotion. Quickly looking at the BCF GUI and doing a refresh, you can see that VLAN 41 is enabled on ESXi 2, but so far still exists on ESXi 1. vCenter now shows that the move is complete and Web 1 is on ESXi 2. When we refresh the BCF GUI again, we see that port group 41 is now on ESXi 2, and since Web 1 was the last VM on port group 41 on ESXi 1, the port group has been pruned from that host. Updating the endpoints, you see that Web 1 is now on ESXi 2. Let me emphasize again that we're jumping over to the BCF GUI just to observe the results. We didn't make any changes directly to the Fabric controller. All changes were made in vCenter. The last part of our demonstration is to observe the visibility into the physical and virtual network that the Big Cloud Fabric Analytics provides to the vSphere administrator, increasing his or her ability to monitor and troubleshoot network issues. In the BCF GUI, we go to the VMware vCenter page. We click on the vCenter name, and we get a snapshot of the vCenter configuration we created in the previous steps. On the top left is the summary showing the number of port groups or networks, the number of hosts, and the number of VM endpoints. Under Configuration, you can observe the tenant connected to the vCenter, the version, and the time of the last update. Below Summary and Configuration, all of the hosts in the vCenter are displayed. Their VM NICs are shown, and the physical fabric interfaces to which the hosts are connected are shown. For example, ESXi 1 is connected through VM NICs 1, 2, and 3 to Rack 1, Leaf 1, and Rack 1, Leaf 2, lag 37. Below the host section, at the bottom of the screen, information about all the VM endpoints is shown. This includes the VM name, its state, a description, how long it's been active, and when last moved, its IP and MAC addresses, its lag, and the VLAN ID. Notice Web 1, which we moved, shows the time of the vMotion. All of this summary information helps the admin to get a quick understanding of the Fabric configuration to begin a troubleshooting routine. Now let's select Visibility and go to the Fabric Analytics dashboard. On the left is a menu of pre-configured dashboards for the physical and logical components of the network. The physical dashboards let you look at various aspects of the Fabric and the controller. The logical dashboard shows different details about tenants, segments, endpoints, and VM networking. Let's select VMware vCenter under VM Networking. Here you can see a graphical representation of all the virtual machine names. When you click on a particular VM, it gives you information specific to that VM, such as when it was added, PNIC information, port groups, and so on. Clicking on a particular event, you see event details. For example, here, you can see an event in which the VM adapter attached to network VLAN 41. You can also zoom in on a time slice. So for example, if vCenter says something went wrong around 12 o'clock, you can zoom in on that time slot and see all the events that occurred then, bringing you closer to determining a root cause. Thank you for watching this demonstration of how BCF, integrated into VMware vCenter, enables dynamic provisioning of your Big Switch data center fabric and provides deep visibility for monitoring and troubleshooting.